This is the second video for 6.3 section trigonometric functions of angles. So here we have instructions, or more like steps, to evaluate trigonometric functions for any angle. So let's go through that. To find the values of the trigonometric functions for any angle theta, we carry out the following steps. So first of all, you have to find the reference angle, okay? Gonna work for me? Of course not. Okay, find the reference angle theta that's associated with angle theta. That's the reference angle theta bar, right? So this is just associated with the angle you're given. Then you have to determine the sign of the trigonometric function of your angle by noting the quadrant that angle is in. And remember, you have quadrants 1, 2, 3, and 4, of course. And if you recall from the other video, we discussed how you can figure out what sign different trigonometric functions have. The value of the trigonometric function of theta is the same, except possibly for the sign, because the sign could be the same, but it could be different, as the value of the trigonometric function of that theta bar. Now, some things that you should probably be familiar with, and it really would be helpful if you would be able to know that right away. So if you have the quadrants, right, we know this is quadrant 1, this is 2, this is 3, and this is 4. So we start with 0 degrees or 0 radians. Over here, we should understand, we probably know that this is 90 degree, of course, right? But something that you may just remember, still learn, is that this is the same as pi over 2. And of course, you can find it by multiplying 90 degrees by pi divided by 180. But this is something you should probably remember without even having to find that. Then if you go semicircle, 180 degrees, this is pi. So if you have pi radians, you just went 180 degrees. Then over here, we have now 270 degrees. And again, you should remember the fact that this is the same as 3 pi over 2. If you go around the circle, full circle, you could be at 360 degrees or 2 pi. So let's look at some examples using the reference angle to evaluate trig functions. So how do we find sine of 240 degrees? First of all, we have to think, okay, so which quadrant is this angle in? And drawing a diagram is always helpful. So of course we went more than 180 degrees, so more than half a circle here, right? So because 240 degrees minus 180 degrees is 60 degrees. So we went half of the circle, 180 degrees, and then 60 more. So that puts us in the third quadrant. Now, if we want to draw our reference angle, this is an angle that's acute. where we use our terminal side of the given angle, and we draw a segment from that terminal side to the x-axis. And this becomes our theta bar. And this angle, as we know, went 180 and then 60. So our reference angle is 60-degree angle. Now we have to recall what we know from special triangles, right? So the side across the 30-degree angle, which would be here, would be 1. Then the hypotenuse is twice as long, so it's 2. And the side across 60-degree angle is square root of 3. What we have to keep in mind is that where are we here? So this is -1 because we are on negative sides of the x-axis. That's r. And this is our y, which also is negative because it's on negative side of the y. So when we do sine, we know sine is opposite over hypotenuse. So let's see, opposite is negative square root of 3 over hypotenuse, which is 2. So our sine of 240 degrees is negative square root of 3 over 2. Now I talk a lot about those signs. If you memorized the table in which quadrant given ratio is positive and where it is negative, then of course you just can do a sine of 60 degrees and just remember is it positive or negative. I don't like remembering a lot of things if I cannot understand them, so I always like to draw this diagram and do the signs, so that actually I don't have to memorize the table and knowing where it's positive, negative, because I can figure it out from the diagram. Now, the second problem B is cotangent of 495 degrees. So if we recall, cotangent is the inverse of tangent. So cotangent will be the adjacent over the opposite. Whoops, opposite, there we go. And we can see that we definitely went around the circle one time because it's more than 360 degrees. So if we subtract 360 degrees from that, we get 135 degrees. So again, let's try to draw the diagram. So we went around the circle once, and then we have 135 degrees more to go. So where does that put us? We know that we went around 90, right? This is 90. So 135 minus 90 is 45. So that means to complete our angle theta, we went just 45 degrees more here, right? This is 45 degrees. So that's the whole angle of 495. Now for our reference angle, we just drop the side toward the x-axis. Here we go. So we know this will be our theta bar, which is also 45 degrees, right? 45, 45 is 90. So we have special right triangle 45, 45, 90. And in that triangle, we should remember that this side is 1, this side is 1, and the hypotenuse is square root of 2. We are in second quadrant. So if you remember what ratios are positive, which ones are negatives here, you can apply that. Or you can simply look, okay, so here is the x-axis, it's negative. This is y-axis, and it's on positive, so that's positive 1. Now we have adjacent over opposite. So adjacent of that angle is here. Opposite is this, so it's negative 1 over 1, which is negative 1. So cotangent of 495 degrees is negative 1. example 4, using again same thing, using the reference angles to evaluate trig functions, but now we have angles in radians. So over here, how do we do that? So we can definitely see we went more than a circle in 16 pi over 3. And how we can look at that? Because sometimes the radians are a little more difficult to understand and figure out where we are here with that angle. So let's think about it this way. We know that 2 pi is a full circle, right? Full pi, what is full pi with a denominator of 2? It will be 6 pi over 3, right? Because that just is 2 pi. So that's already full circle. Now, how would we, I think we can go even another circle, right? Because another circle, it will be 12 pi over 3. So 12 pi over 3 is 4 pi. So we went 2 circles now. This is 2 circles. Okay, so if you went 2 circles, what's left then? 16 minus 12 is 4 pi over 3. That's what's left. Now, 3 pi over 3 is 180 degrees, right? Because that's just pi. So let's see, this is the same as 3 pi over 3 plus pi over 3. This is 180 degrees, if you recall, half circle. And then we just have to go pi over 3 more. So we go 2 circles, then half a circle, and then pi over 3 more. So let's see if we can draw that. Oops. Okay, I apologize for the lines, but again, technology is not working ideally for me here. Okay, so we went 2 circles, 1, 2, right? Then we said we go this here, half a circle, 180 degrees, or pi. And then we need to go pi over 3 more. So there we go. And if you recall, pi over 3 is 60 degrees, right? So let me put it like that. Okay, there we go. So to draw a reference angle, you again drop a right angle onto a x-axis. So this is pi over 3. And again, it's the same as 60 degree angle, right? So if across the 60 degree angle, we know this is square root of 3. The short leg is 1, and the hypotenuse is twice as long as the short leg, so it's 2. So these are our values. Now sine is just opposite over hypotenuse. So opposite, just let's talk about the positive negative sign. So over here again, you can either just remember that from the table where is positive, where are negative ratios, or you can see here this is negative because it's on negative side of the x-axis, and this is also negative because it is on y-axis but in negative direction, and that's the r, right? Now, sine of 16 pi over 3 is using this reference angle, pi over 3 is the reference angle, is opposite negative square root of 3 over hypotenuse, which is 2. So there we go. This is the value. Okay. And the last problem over here, it's B, secant of negative pi over 4. So what do we have here? First of all, we need to remember that secant is hypotenuse over adjacent, right? It's the secant is the inverse of cosine, and it's negative. What that means, we just go, instead of going counterclockwise, we go clockwise now, okay? So here, let's draw that. And it's just pi over 4, so that's not that easy. We don't have to figure out how many circles we go or so, because it's just a small angle. So we go the opposite directions that we normally go, pi over 4, which is, recall, 45 degrees. We again drop aside toward the x-axis, making a right angle with it. This is pi